Hi everyone, welcome back to another episode of Phys 3500 Classical Mechanics. I'm your professor, Dr. DJ Hammond. Today we'll be discussing again Lagrangian and Hamiltonian dynamics, and this is from chapter 7 of your textbook. This will be a fairly short video because most of the slides that I have here will be just covering examples, which we'll be going through in the lecture and the tutorial as practice, so you have a lot of practice in seeing problems, multiple problems for your assignments and for your midterm, which will be next Friday, or the Friday after reading week, I should say. So midterm number 1 is on Friday, October 23rd, so the Friday after we get back. I'll post the exam at 9 a.m. on the Friday, and it's due at 7 p.m. on the Friday. Late exams won't be accepted, so don't start it at 5 o'clock Friday night, because you will be submitting it late, and I will not be accepting those. The reason why I'm not accepting those is because I would like some limitation on you being able to search for solutions or ask friends for answers, or worse yet, post the question to something and then wait for the answer. So submit this to Blackboard. Blackboard has a timestamp on it, so I'll know when you submit it. It should only take 2 hours. Of course, most of you have written exams with me, so it might take you 2.5 hours or something like that. But we have the tutorial and the lecture time for you to work on this. So you have 2 hours to work on this exam. In fact, that's when I would hope that you would be writing the exams, from 10:30 to 12:30 on the Friday. And hopefully you'll have it done then. I understand if you want to go back and check your work or something like that. But that's why there's kind of a finite time limit to it. There will be a derivation, but of course, since you can go back and check your notes and you have your textbook, I will be asking you to interpret the derivation. So memorizing it won't help or just having the textbook in front of you isn't going to help as much as you'd think, because it's going to be understanding why we do the steps in the derivation, and what do you interpret the derivation to mean. So this is going to cover the material of everything that we've seen so far in the course. So that's chapters 1 to 3 and 5 to 7 from Thornton. So of course, chapter 1 is basically just the math, making sure you have vector calculus and the linear algebra necessary to be able to do this course. Chapter 2, Newtonian mechanics. Chapter 3, harmonic motion. But we will only be covering harmonic motion, undamped harmonic motion, because this course we were only covering conservative forces or conservative systems. Chapter 5, gravity, that will include a little bit from chapter 8, but basically it'll be gravity as a central force would be kind of the way that would be covered. Chapter 6, of course, calculus of variations, and chapter 7, which we've been doing for the past few weeks, Lagrangian and Hamiltonian dynamics. Obviously, chapters 6 and 7 are new for you, and so that will be the emphasis for this course. Also, we've covered these chapters will be, I think, 5 weeks out of 6 will be on these 2 chapters, so obviously they will be of greater significance. I haven't finalized it yet, so any of this is subject to change, but this is what I'm going to be shooting for. So again, I'll be posing this question in class. Do you guys want to cover the phase space and virial theorem? You guys had said that you want to discuss this on Friday, so we'll do that in class. They won't be on your exam either way, but we do have a little bit of extra time. The way that I've set up the course, we end up covering chapter 8, and I think we have 2 weeks to cover chapter 8, which we definitely don't need. And so having an extra class or 2 on covering phase space and virial theorem might be a good thing to do. So let me know. And then the rest of what we'll be covering in lecture and tutorial will be several examples. So I have 5 examples posted, so I'm sure that will take up all of our time. All right, so there will be also an assignment posted, or there is an assignment posted that is not due on the day of your exam. It's due the Friday after. However, I recommend that you do it because, of course, it's going to be on Lagrangian and Hamiltonian problems, and so you can use those as basically a practice for your exam. All right, looking forward to seeing you in class.